Okay, now we're going to look at example problems. All right, find the area of this quadrilateral. Okay, and if you look closely at this quadrilateral, ABCD, it's actually made up of two triangles. Okay, a lot of times students look at this and they're like, what? I can't tell what to do. Okay, you can either break it up into triangles or quadrilaterals or rhombus, if you've got one. And I see triangles, and actually there's lots of little triangles, but, whoops, I'm going to try. Aha, do you see that triangle right here? This is going to be one of our triangles. And there's our other triangle right here. Okay, so AC is 35. So I'm going to move this triangle out, and I'm going to label that side of it 35. BF is 18. That's that little piece right there. And DE is 10. So that's on this other triangle is 10. Oops, once again. There we go. This is our 10 right here. And once again, this 35, that's this piece right here. That's the same for the bottom of that triangle, and it's the same for this triangle right here. All right, the formula for the area of a triangle is 1/2 base times height. So I'm going to take this triangle right here, and I'm going to take this triangle area and add them together. 1/2. The base is 35. The height is 18. Okay, quick calculate what that is. So we have, this is the thing about you guys watching this. I know you are probably not taking it times 1/2 and then taking it times 18 because you are watching me do it. So 315 is what I've got for this. 35 times 1/2 times 18. 315. All right. Same thing. I need to do the same idea with the other calculator. The other triangle. Hello. Why is it going down here? Okay, so we're going to have 1/2. The base of this triangle is also 35, but the height of this triangle down here is 10. So 1/2 times 35 times 10. So that's 350 divided by 2. Then that's going to be 175. All right, we're going to add those together, 315 and 175, and we're going to have 490. So 490 square units is the area of your two triangles together. Okay? That's the full area of the quadrilateral. All right, area of a trapezoid. Oh, what's the formula for that again? Test yourself. Could you write it down right now? Press pause, see if you can do it. Oh, you didn't press pause. Imagine that. 1/2 times the height times base 1 plus base 2. All right, so we're going to take 1/2. What is the height of this trapezoid? I'm sorry, this is, right here. The height is 3 units. The base 1, it doesn't matter which one you call base 1, but I'm saying that base, I got 1, 2, 3, 4, 5, 6, 7 units. Plus the top base, 1, 2, 3, 4. 4 units. All right, so this is actually 1/2 times 3 times 11. All right, 33 divided by 2 is, I'm going to say 33 divided by 2, and you're going to get 16.5. So the area of this particular trapezoid is 16.5 square units. And of course I've already told you, I think I've told you the story about how trapezoids remind me of raccoons. Oh, yeah, I don't need to tell that story again. Moving on. Find the area of the rhombus. Quiz yourself. Can you write down the formula for the area of a rhombus right now? Press pause, see if you can do it. Oh yeah, I'm sure you all press pause. Here you go. It's 1/2 D1 times D2. It does not matter which diagonal is which. All right, let's look at my picture here. D1, D2. How am I going to find the distance? It's not rise over run. Rise over run is slope. I actually have to use the old distance formula to figure it out. So here I go. The distance formula, I'm going to take this from here to here. I'm going to take -1 minus -2, which will be plus, square it. I'm going to take 0 minus 3, square it. Remember, distance formula is Pythagorean theorem in disguise. Is your a squared plus b squared equals c squared. Except to undo this c squared, you square it up. All right, here we go. Keep going. We got 1 squared plus -3 squared. D is equal to 1 plus 9, which is the square root of 10. So I've got my D, I'm going to call that D1, is square root of 10. Got to keep going. I got to find D2 now. So I'm going to call D2 the distance from 4, 2 to -1, -3. So here we go. 2 minus -3 plus 4 minus -1, which is actually going to be a plus, and I'm going to square that. So this is equal to 5 squared plus, that's supposed to be a 5 squared. So now I've got square root of 25 plus 25, square root of 50. That's what your D2 is. So if I go ahead and do the math on this, I'm going to have the area is 1/2 D1, which is square root 10, times D2, which is square root 50. Okay, that's 1/2 times the square root of 500. And once again, I know I kind of alluded to the fact that we should do everything in radicals, which would be my favorite, but I think we're going to kind of default with what the book does. So you're going to take 0.5 times the square, oh dear, I never know with this, 500 the square root times 0.5, or 1/2. And I'm getting an area of 11.18, which will be 11.2. All right, and this will be units squared. I don't think it says what decimal point to give it out or anything. It just says find the area. Okay, moving on. Trapezoid, this time they're telling you what the area is, and you have to find the height. So let's write out the whole formula. Don't try to do this without writing out the formula. You're going to have A is equal to, oh, press pause. See if you can write down the answer to the formula. Give yourself lots of practice doing this. All right, 1/2 height, base 1 plus base 2. All right, what do I know? I know that my area is 210. I know that 1/2 will not change in this formula. The height is what I don't know, and I want to figure it out. Base 1 plus base 2, they're interchangeable, but I'm going to put down 50 plus 20. All right, and then I keep doing my math. All right, 1/2 times, I'm going to put 70, and then I'm going to put the H. It's okay to do that because in multiplication, order does not matter. So 210 is equal to 35 times H. Divide by 35. All right, H is equal to whatever 210 divided by 35 is. And it looks like 6. And what units are we going to be doing this in? It looks like yards. So your height is going to be 6 yards. All right, I'm going to ask if there's any questions, but since nobody's actually sitting in my room right now, we're going to move right on. You can ask your questions in class if you have. All right, this window hanging is composed of 12 congruent trapezoidal shapes. The total area of the design is 216 square inches. Each trapezoid has a base of 4 and 8 inches. So each one of these little ones has a base of 4 and 8. Okay, find the height of each trapezoid. Now once again, it's not the slant here, it's actually how tall that is that I'm looking at. So once again, it kind of similar to the problem right before this. 216 is my total, and sorry, I'm getting off track here. 216 is the total. I got to figure out how many trapezoids. Got to narrow it down to one trapezoid first. So 216 divided by, I see 12 trapezoids. Is that what you guys are seeing? Oh yeah, great feedback, guys. 216 divided by 12 gives you 18. So I have 18 I mean, the area of each trapezoid is 18. So this one's 18, this one's 18, this one's 18, and so on. All right, so that one trapezoid has an area of 18. This is going to be worked out like the previous problem. 18 equals 1/2. I don't know the height. I keep going. Base 1 is 4. Remember, that's this little piece right here. And then the height, or the other base, is 8. That's going to be the same as 1/2. 18 is equal to 1/2, and I'm going to 8 plus 4 is 12 times h. Keep solving. 18 is equal to 6h. So now h is equal to 3. And that is, once again, the height. So the height of one of these little trapezoids is 3. I'm going to go back and check, make sure I actually answered the question they asked. Find the height of each trapezoid. Okay. All right. That concludes the example portion of 11.2, areas of trapezoids and rhombus and triangles. Have a nice day.